Example 2 says that the quadratic equation x squared minus kx plus k plus 3 equals 0 has two real and equal roots, and it says where k is a constant. So it's some number that we just don't know what it is. A asks us find the possible values of k, and B says hence for the smaller value of k found in A, find the roots of the equation. So it's very interesting. So it's saying that there's multiple values that k can have. Now, why would that be? How can I figure that out? Well, so let's think about what we know about this already. So we do know that we've got this equation. We've got x squared minus kx plus k plus 3. Well, this has 4 terms. That's really odd. That equals 0. And we know that it says that it has two real and equal roots. Well, what does that mean? That means something. Two real and equal roots. This part, that implies that b squared minus 4ac equals 0. Right? You remember that? It's a quadratic equation, so two real and equal roots guarantees that our discriminant is going to equal 0. So we know that. We can use that to our advantage. So now what we have to figure out is what's A, B, and C. So we have to think carefully about this. A represents the number of x squareds we have. So, oops. There's one x squared. Right? So B represents the number of x's we have. Well, if I look, I've got a negative kx, so that's B. Now C represents the constants. Now you may want to say that C is 3. But what about this k? What is k? K is just some number. We don't know what it is. K is actually a part of the constant. We just can't add them together because we don't know what k is. So we have to extend this entire part as C. That makes things a little different. But we can use this together to make everything make sense. Now, if we use our formula, we could go ahead and start trying to dig at this problem. Well, if I know A, B, and C, and I know that b squared minus 4ac equals 0, let's go ahead and start plugging some stuff in. So I know that negative k squared minus 4 times 1, which is A, times C, which is k plus 3, that equals 0. That is a true statement. Very cool, huh? So now I need to go ahead and simplify this. I want to know the values of k. So this here, funny enough, what kind of equation is that? We know k is a constant, but we're solving for it. We're thinking of it as a variable right now. What would make this true? This is actually a quadratic equation. So we can actually use the rules that we've been learning to deal with this. So let's simplify. So if we simplify this, negative k squared is k squared. Negative 4 times 1 is negative 4. And we can then, so this is negative 4. We can multiply that by k to get negative 4k. And then we can multiply that negative 4 by 3 to get negative 12. That equals 0. So now you can see this is a quadratic equation. So how am I going to go about doing this? So you can either factor, you can use the quadratic formula. Those are all very excellent options. You could graph if you want. I think that's kind of clumsy. So pick factoring or a difference of squares, I'm losing my mind. The completing the square or quadratic formula or factoring. So I'm going to factor. I see a pattern. Two numbers that can multiply to make negative 12 that can add to make negative 4. I can see that as negative 6 and a positive 2. So this tells me that k minus 6 equals 0 and k plus 2 makes 0. So k is either 6 or negative 2. So those are two options. Both of those options would result in two real and equal roots. It's very interesting. So if we go back and think about what part B says, it says, hence, for the smaller value of k, find the roots of the equation. So our smaller value of k is negative 2. So we're going to go back and make k negative 2. So I'm going to erase some of this stuff, and we're going to go ahead and make k negative 2. Very cool. So if I say, okay, well, k, is negative 2, and this k over here is also negative 2, then we're going to sit here and we're going to simplify and say, okay, well, this is x squared. We've got positive 2x, and then negative 2 plus 3 is a positive 1. Well, if I think two numbers that multiply to make 1 and add to make 2, 1 and 1, which means that x is going to equal negative 1 and negative 1. Look at that. Two real and equal roots. Two real and equal roots. And this is all based on this one little statement here that says we know something about this equation, even though there's some things we don't know. We can put them together based on some logic.